Today's topic is on urban soil solutions. Our objective today is to discover different strategies to increase the health and longevity of trees planted in difficult growing environments within the urban forest through careful selection and site preparation. So in other words, what I want to do today is to look at if we're on a budget and we can only afford to plant so many trees, we want to make sure those trees are going to survive. So our goal is to look at sites and find out where can we plant trees that are going to be the easiest to plant, and eventually end up today looking at what are we going to do with the difficult places where we need to put some green vegetation there, but we need to improve methods in ways for them to grow. So for step one, and these are steps out of James Urban's Up by Roots suggestions through his book. And step one, according to Urban, is plant the easy sites first, which makes total sense. There's lots of soil, lots of space to grow. So in this case with these trees, park setting, there's lots of good soil, probably remnant soil that hasn't been overly disturbed by human impacts. The trees grow large in diameter because they have the soil and the space to support themselves to grow. As we move into more difficult urban areas of growing, we get into sites like this, and we have what we could call a tree island, okay, or a boulevard strip or a median here, that green median where trees have been planted. This, it's a little more limiting, obviously a lot more limiting. There's more asphalt in the area. It's going to be more difficult for those trees to reach a longevity or to grow to their maximum potential because there is more limitation in probably moisture, possibly compaction, so oxygen in the soil, and just less soil volume in general. And then finally we get down into here. This is a great example of the difficult places. This is a tough spot to plant a tree, and what we all seem to call the tree coffins. Unfortunately, where trees go to die in many cases because there is just not the support for those trees. Okay, studies have shown that trees require a certain amount of soil volume in order to survive and to maintain their health and longevity. So in this example, and I'm sorry it's all imperial, in the field of urban forestry, although we talk metric in schools, there's very much imperial and metric measurements used, so it is good to be familiar with both versions if you can. So here we have imperial units of cubic feet of soil volume. It's saying that for a tree that is 16 inches in diameter, which works out to about 50 centimeters, so 50 centimeter diameter tree, it requires 1,000 cubic feet of soil. Okay, and that's not what's getting in those tree planters. Okay, there it might be getting a 4x4 spacing, and off the top of my head I believe that's about 64 cubic feet of soil. Okay, that a tree when it is young, so a 50 millimeter caliber tree is being planted in a coffin, tree coffin of 4 by 4 by 4 feet, which is a meter by meter by meter roughly. It's not near enough soil. Okay, so when that tree reaches its maturity, it requires, in maturity in this case they're saying on average would be about a 50 centimeter tree, which we know is still not the case, but that would at least provide place for it to grow for much longer than they're actually surviving now. The other interesting point to notice is that a tree that is a 16 inch or 50 centimeter diameter tree that has 1,000 cubic feet of soil to grow in also has the capacity to store 200 cubic feet of stormwater, which you can see that in an urban environment that is a benefit, that it is not only the soil providing more ample space for larger trees to grow, but it also helps to retain stormwater runoff, which otherwise would be lost and wasted. This is just an example, perhaps you've seen these or grown them yourself, of a bonsai tree. And essentially, if you're not familiar, a bonsai tree is just a tree that is grown in a very limited space, such as a pot like this, and is kept up with constant maintenance and pruning of these branches. So it ends up being like a miniature tree. So the pruning and the maintenance is part of it in order to kind of maintain that size, but its limitation in the first place is because there's not enough soil volume to support the tree to keep growing. So a tree that does not have ample soil volume will not continue to grow. So you'll find trees that might survive on a site with limited soil volume, but they end up being stunted, small, they can't put on more growth because the tree knows that there's no point in keeping growing when there's not enough soil there to support it. And it's the same scenario if you're familiar with Niagara Peninsula or anywhere where there's bluffs and stony ground where there's not a lot of soil. The trees growing there are typically more stunted and growing smaller because there's just not the volume of soil to support it. So the tree cannot extract all of the nutrients and the energy that it needs from that soil because it lacks. Step 1, we planted the easy sites. Now step 2 is make or create larger planting sites. Okay, minimum size of ground space required for supporting a large canopy tree is 20 by 20 by 3 feet deep. Okay, and that gives us roughly 1,200 cubic feet. So that goes back to that slide you saw previously. The typical planter gets 64 cubic feet, and that is again the 4 feet high, 4 feet wide, 4 feet deep planting site. Okay, the typical tree coffin. What a tree needs, instead of 4 by 4 by 4 feet deep or 3 feet deep, we need more 20 feet by 20 feet by 3, a much broader area in order to support the tree. Okay, so instead of this, and roughly where this tree grate is on top, looks like a concrete tree grate, that area is all the tree gets for good soil to grow in. Instead of that, maybe we could look at options like this. Here we have Freeman Maples growing in town. This is right in Toronto, in a raised planter bed scenario. There are multiple trees in this grouping, and obviously it's being irrigated in this picture. But the trees here are able to network. They grow more in a community or in a colony, quite similar like they would in the wild. So here's another example. There's different all the trees within this similar place in one same spot. Okay, trees are planted in clusters or in groups here. It increases soil volume because there might be less trees on the street in this case, but there are still the same amount of trees in the area, just they're less spread out, so they're more clumped together. This way they share that soil volume. Okay, so although one mature tree at 50 centimeters diameter might need 1,000 cubic feet of soil, having multiple trees in that area reduces that because they end up sharing that. So you can plant more trees within that same amount of soil. So that's more of a value as far as a cost benefit there. Also, by clumping trees, it helps with breaking down the amount of vandalism. Okay, typically when trees are clumped together, there seems to be less vandalism for that clump as opposed to a single tree standing by itself on a street side. The benefits of the tree, soil, and root networks are much greater for these trees. Okay, naturally in a forest, trees grow together. Their roots benefit by mycorrhizal relationships. They're able to network this way. The roots may even end up root grafting, supporting one tree and the other. So there are very many positive reasons to look at planting trees in clusters or in groupings like this. As far as maintenance go too, the sustainability, it's easier for a crew to stop in one location, set up, do the pruning and the maintenance work that needs to be done, as opposed to be setting up and moving down the street every so many minutes or half hour or so as you do the maintenance. So many benefits to doing it this way if you have the space. Okay, in other areas, now this isn't a great example, but what I'm looking at here is a long planting bed. Okay. Okay, so as opposed to, again, having, let's say, the cutoff line is right here, and having this tree in a little tree coffin, here we have like a long trough, if you will, or a long planting bed, which this way we can plant maybe 2 or 3 trees in the same area. They have more soil to share. Right in here you can see that there is some drip line irrigation, which we'll talk about later this semester, as a means to irrigate these trees. Now, unfortunately, the maintenance hasn't been kept up with this bed. You can see a bit of mulch, but there should be, another tree or 2 in here. So, still some issues with that. Just more so the specific one. But the idea of having a long bed like this is beneficial because it still gives lots of pedestrians space to be walking. It doesn't take up a lot of space, and once again increases the soil volume and makes a connection through root pathways from one tree to the other. Okay, another point would be to respect the tree's taper. Many municipalities use tree grates around their tree coffins, and unfortunately it often becomes the lid to the coffin. Okay, they are created, they look nice, and part of it is for appearance, aesthetics. Part of the reason they use these is for liability, because if they left the pit open, the fear is people might fall and roll their ankle as they step from the concrete onto the mulch bed. So they put these in here thinking they look nice, they're safer, but the downside is the steel of the tree grate does not increase in diameter as these trees grow. So many times, and especially if not maintained and taken away, that tree grate will become the girdling point for the tree if it grows into that. So when planning these sites, make sure we take into account the future size of the tree, so it doesn't become something like this. Concrete and the sidewalk has been poured right close to the trunk flare. The trunk taper was not respected. The tree didn't have room to grow, and now we have planners looking at this tree saying, "Oh, it's a problem," when really it was not the tree that was the problem. It was the misunderstanding of how this tree will grow that was the problem in the first place. And so our infrastructure has failed because of poor planning in this case. Next step is, let's preserve the existing soil. Good soil is irreplaceable, and in urban environments we do not have a lot of good soil, as we've talked about this semester. And it's not, well, there are measures slowly to kind of help us recognize good soil and to not be so wasteful with our practices. But still, the quality and quantity of good soil is a diminished feature in the urban environment. Adding good soil after construction is better than nothing, but still is not as good as what was existing as undisturbed soil. And this is just a photo that breaks my heart. It was a woodlot that was purchased, clear cut, and then all the original soil, which was this grade level, has been increased with fill, and typically it is just nothing but fill. So rubble from construction sites that has been bulldozed in and leveled out in order to raise the grade, destroying this once natural forest setting. So once this happens, once disturbed, forever disrupted. It would take generations before that soil, if it was left untouched now, would ever be able to sort itself out into creating kind of that natural soil profile. Okay, so if the soil is deemed fit to preserve, some protection measurements may need to be implemented. And just a quick quiz question: what soils may be better preserved than replaced? We've talked about this several times through the semester, so I'll leave you to think about that. Tree protection zones might need to be implemented, and that's not only for the trees protection, but it's also for the protection of the soil and the entire condition of the tree and its surrounding areas. So in many municipalities they are starting to look at this as well. Along with the tree protection zone is what is the soil plan, and how are we going to preserve the soil. So this is a new feature, relatively new feature, and I think we'll be seeing more of that in the future. Okay, if we have a poor site or a natural site that needs some amending and some fixing, again, compaction is a very difficult process to correct, because there's things we can do, such as these tools here, which are what we call subsoilers. They are meant to just get down into the soil and break up the soil, just to allow more oxygen into the soil and break up the compaction. Okay, it's effective, but still not as good or as original as if it was not compacted in the first place. So there's a subsoiler at work. You can see the furrows are down into the soil, digging up quite deep, and just kind of leveling off afterwards, so that it just loosens up the soil. But again, it's still not as effective as undisturbed soil.